So this is Thanksgiving week, which means there's still 11 weeks of fun left in the Moog Circuit Bending Challenge for 2014. The first blog was about hacking an easy button. That was a fairly straightforward circuit bend, because all it required basically was a screwdriver. Now, for the circuit bending competition, the idea is to make it a musical instrument using something that's not normally musical. Now, a musical instrument typically makes a lot of noise, and preferably the louder the better, I think. So for this competition, I'm using an alarm clock radio. I bought the alarm clock radio at Staples. The competition rules this year state that you need to be able to provide step-by-step instructions so that someone else can build your bend. It also says that the items must be battery powered by no more than 9 volts. So one of the consequences is that you need to find something that will be available next year. Given this is Thanksgiving week 2013, in April 2014, when the competition being judged, a lot of things might not be available. So that's why I did the easy button, because I'm pretty certain that's going to be still around. This Memorex alarm clock radio, I expect, will still be around, and there's lots of similar radios like it. So what I'm going to do is convert it into an amplifier, but first I have to make it legal. The competition says it has to be battery powered, while a clock radio is normally plugged into a wall outlet 24 hours a day, and the battery is only there to support the clock when the power goes out. So what I'm going to have to do is remove the power supply components and then rewire the battery so the battery can power it all the time. Once I've done that, I can then try to find out how to feed a sound signal into it so that it can play through the speaker. So that's what this bend's about. Taking the radio out of the box and turning it over, there are 4 screws. These screws can be simply undone with a cross-point screwdriver, and the case halves come apart. The transformer and the power lead are fairly easy to remove by undoing 3 more screws and cutting the wires that go to the circuit board. On the circuit board is a full wave rectifier using 4 diodes. So I removed the 4 diodes because they're no longer needed. There are 2 resistors from the AC input to the display. So I've assumed initially that this was to do something like a backlight or something like that. But looking up the clock chip data sheet, I found that the AC input was being used to multiplex the LEDs, and the clock chip was using one of the inputs to generate the timing signal. So tracing the circuit of the battery area, I see that the battery is connected via a diode to a track, and I'm assuming that that track powers the clock chip. Doing a bit more circuit tracing, I see that there's a volume control with a switch. The switch turns on the amplifier radio area. So what I've done is I broke a track to the switch on the amplifier side, and then shorted the same track to the other side of the track from the other side of the switch, so the amplifier is now permanently turned on. And I can use the switch on the volume control to turn the battery on and off. So now I have a switchable power supply using the battery. The live end of the volume control is fed from the radio. There's a 39,000 ohm resistor. By taking this resistor out and moving it to the other side of the board so I can make changes, separate the radio from the amplifier. I put a jack into the back of the case and wired up the amplifier input to the tip of the jack. This jack is a switched jack, and so on the switched part of the tip connector I put the radio. So with nothing plugged into the jack, the radio is connected to the amplifier and it just works. If you plug something into the jack, then that goes to the amplifier instead. To get the display to work, I have to re-simulate the AC input, which is 9 volts peak to peak. So what I've done is, using a couple of transistors, I've made a simple amplifier so that I can feed in a signal from a oscillator 60 times a second, and this will then, the transistor will drive the LED display, and the signal will also make the clock chip think that we're powered on.
Now 15 north of Rosemont toward 26 again, just a brief way on 15 north toward Gettysburg, westbound on 70 out toward Hagerstown, and 68 toward well, 95 northbound. Again, just briefly, your exit 4, that's wrong.